Yes, hello everyone. Today we are discussing a question based on mechanics, which is based on constraint and at the same time a little bit of rotational motion concept also there. Let us start with this question. It says that a boat is moving with uniform velocity of 20 meter per second, pulling a water skier with the help of a tug rope of length 10 meters. To describe his speed, to increase his speed, the water skier tilts the skis slightly away from the direction of the motion of the boat. As he does so, the tug rope rotates. What is the speed Vs of the skier with respect to the ground and the angular velocity omega of the rope when the angle theta and the phi value is given as 30 and 60 degree respectively? So this is what the question is. Now based on that question, I have drawn one diagram here. You can check the diagram. Okay, so the boat velocity as per the question they have given as 20 meter per second. So this speed is 20 meter per second. This is given. And the length of the rope, the tug rope that they have given is 10 meters. So this tug rope has a length of 10 meters. That's it. Theta is 30 and the phi value is 60. Now, we are interested in finding first of all the speed Vs of the ski. We can get that by using the concept of constraint pretty easily. See, this rope is actually a rigid body. Rigid body in the sense, I'm not saying that the rope is not flexible. The rope is flexible, but it is inextensible, right? You cannot just like a spring, you cannot extend the rope. And if the rope cannot extend, then can we say by using the logic of this constraint that the rope cannot extend, that whatever velocity the ski would have in this direction, let us say it is what component will come Vs cos of phi, this velocity should be equal to the velocity of the boat that is there in this direction. Now if you just extend this, you will feel that this is the velocity Vb. Actually, if this is theta, then this is theta, so this component should be Vb cos theta. Now for this rope to remain in a taut condition, for it to remain in a stretched condition, stretched in the sense not extended, but in a taut condition, that means it is in a tight way. So if you want the rope to remain in that, then definitely these two values of velocity should be equal. You think what would happen if they're not equal? If these two are not equal, let us say this velocity is more than this velocity. Vb cos theta is bigger than Vs cos phi. Then what would happen? This part of the rope would be moving faster and this part would be moving slower. That's not possible. If that happens, the rope would break. Similarly, if this part is having higher velocity and this is having lesser velocity, the rope will no longer remain tight. It will become loose, right? It will no longer remain taut. It will become slack. So the point is, constraint says that V cos theta should be equal to Vs cos phi. This has to be satisfied for the string to remain taut. So Vb is given to us as 20 cos of theta. Theta is how much? 30 degree. And that's equals to Vs, we don't know, cos of 60 degree. This would give me root 3 by 2. This would give me 1 by 2. 2 cancel. I'll be getting Vs is equals to 20 root 3 meter per second. This would be my answer. If I want to simplify it further, I can just multiply it with the rough value 1.73 and that should give me 0, 6, 4 and 3 with one decimal now. 34.6 meter per second. This will be the speed of the ski with respect to water, and if I am assuming the water to remain stationary, then with respect to ground, because they are not given any velocity of the water, so we have to assume the water as stationary. So this is the velocity of the ski with respect to ground or with respect to water in our case. Okay, both are valid. All right, now what's the next thing? They're interested in the angular velocity of the ski, of the rope, sorry. So isn't the rope rotating because of the change in direction of the ski that the man did? Because of that, the rope will be now, initially the rope was like this, now the rope is rotating, right? And they're interested in the omega of the rope. Now, a simple way of finding omega is like this. I can say that omega is nothing but the perpendicular velocity, that is a tangential velocity divided by the V tangential divided by the radius of rotation. So what we will do is we can name these 2 points by something. Let's say I can call this point as A and I'll call this point as, let's say, B. Okay, like that 2 names I can give. Now Can we find out the velocities perpendicular to this rope? Velocities perpendicular to the rope. Can you find that component? So for example, if I'm trying to find this component, can I say this would be Vs sine phi? Okay, I'll just use my black color then. It is, I can call it as Vs sine phi, and same way here also I can have one Vb sine theta, two components. So if I assume to be as an observer standing at this point as an observer, if I look at this rope, then what is the relative velocity of the rope tangentially? What can you say as the velocity of A, velocity tangential at A with respect to B? With respect to B. I hope you understand what I'm saying. If I am an observer standing at point B, and when I look at point A, the point A will feel like going in a circle, right? So I'm interested in finding that omega. Now for finding that omega, I need to know how it is moving. What is the velocity of that point A with respect to me as the point B? So that's what I'm trying to find out. And which velocity? I'm not interested in this. This is not giving me the circular motion. The circular motion is happening because of the perpendicular velocity. So I'm finding out velocity of that point A tangential with respect to me as an observer standing at B. That will be given by this equation, Vt of A minus Vt of B. Now what is the V tangential at A? That is nothing but Vs sine phi, and Vt of B would be Vb sine theta. Okay, now sine phi value would be sine 60, which is Vs. How much is the Vs that we calculated? 20 root 3. So I can write it as 20 root 3, and sine of 60 would give me root 3 by 2 multiplication, and minus Vb value is 20. 20 into sine of 30 would give me 1 by 2. So this comes out to be 10 and 3, 30 minus 10 equals to 20 meter per second. This is the velocity of A seen by an observer standing at B. So A is moving with a velocity of 20 meter per second. The hand that I'm showing is the rope actually, and the rope is rotating like this with respect to the observer B with this speed. Now use that directly here and solve it. So omega is given as the V tangential, which is 20 that I calculated right now. So 20 divided by, what is the radius of the rope or the length of the rope that we have? It is 10. That's it. So this gives me 2 radians per second as the omega. A very nice question for us to understand two things. One, constraint, how a constraint works. And the second one, very important thing, is how would you find out the omega for a rotating body? Right? So any body which is performing rotation, if you want to find the omega, just stand at one of the points where velocity you know, or about which point you can calculate velocity. Those kind of point anywhere, you can consider yourself standing there as an observer. Then you see that what is the velocity of the other point with respect to you. The tangential velocity obviously, and that tangential velocity divided by the length, the distance, would obviously give you the omega at that point. Okay, you know the formula, V is equal to omega r. From there we got omega is equal to V by r. That's it. It's a very nice question for this concept. I hope all of you have understood. Thank you.